In this video, we are going to be finding trig functions at any angle and how to write those functions. All right, trig functions at any angle. In the past, we have talked about initial side and coterminal side. So when you think of it in terms of, of this side right here, we know that it's the hypotenuse when you make a right triangle. But if you also think about the fact that this is the initial side because it is the positive x-axis and we are moving to a terminal side, we are creating an angle. So if you think of this as a coordinate point, to take an initial side and we are rotating some segment around a coordinate point, around a coordinate plane for this angle, this is a hypotenuse. This is your x-axis. Why? Because you went along the x-axis and then you went along the y-axis. So if you think of this as this is the adjacent side, this is the opposite side for a hypotenuse, if you remember SOHCAHTOA. This coordinate point, you move along the x, then you move along the y. That is how you get to this coordinate point right there. Now, if you think of it in terms of Pythagorean theorem, you can actually find r, which is the hypotenuse. Okay, so again, if you think of this in terms of you go x to the right, you go y to the left, you're able to find this length, this hypotenuse length, by using Pythagorean theorem in the x coordinate and the y coordinate. If you're going to quadrant 2, what would happen is you would create a separate theta, what we call theta prime. And to get this coordinate point, you go in the negative x direction, and then you would go up y. Again, this is your adjacent, this is your opposite, this would be your hypotenuse. So r never changes because it's a length. When you take the Pythagorean theorem, you would still get a positive number. But if theta is going from the initial side, this becomes, if you remember, this becomes your reference angle. Remember how we discussed in the past that the reference angle is the distance, the angle distance from a terminal side down to the x-axis, to the shortest distance to the x-axis. So this actually becomes your reference angle. And that is why reference angles are important, is because you can still find the different sides of the triangle with them. It does not change the fact. So if this right here is 120 degrees, this right here would be 60 degrees inside the triangle. So again, as we discussed, if this is the initial side, this is the terminal side, this right here becomes theta prime. And to get to this coordinate point, you would go negative x, since you had to go to the left, you would go up y. So this technically would be negative x, comma, y. So using the reference angles for it, if it's in the second quadrant, then you would use the reference angle to find whatever is inside the triangle. If it's in the third quadrant, you're looking for the reference angle that's moving back up to the x-axis. So again, and then the reference angle in the fourth quadrant, you're moving back up to the x-axis because it has to be inside the triangle. So here is the cool thing that happens. Again, if you think of this as an angle, this becomes your hypotenuse, this becomes your opposite side, this becomes your adjacent side, right? This is x, your opposite side becomes y, and this is your hypotenuse, which would technically become, in this case, r would be your radius. So if I, for example, wanted to find the sine of theta, it is going to be my opposite, y, divided by my hypotenuse, which is r. If I wanted to find cosine of theta, it would be my adjacent divided by my hypotenuse, which is r. And here's something that is really cool. I want you to solve for y here. If you solve for y, that means you're going to multiply r times the other side. And I want you to solve for x here. So if you solve for x, you would have r times cosine. So you actually can find a coordinate point by using sines and cosines. So here's actually what happens. We know r, this looks really weird, but this is just the Pythagorean theorem. So sine of theta is going to be y divided by r, cosine is x divided by r, tangent is y over x. Because if you think of it like this is y, this right here is x. So tangent is just opposite over adjacent, it's y over x. And then again, in the past, we discussed cosecant, secant, and cotangent, which are just reciprocals of sine, cosine, and tangent. And so that is why it is the opposite, it's not the opposite, it's the reciprocal of those. So, for example, let's use the point -3, 4. So here's -3, here is 4. All right, and we're going to create a terminal side. And we want to know the 6 trig functions. So what you do is you draw a triangle using the x-axis. Do not draw it this way using the y-axis. Never, never, never. Always use the x-axis. So I know that I have to go over -3 and I have to go up 4. So the first thing I'm going to go ahead and do is find out what is r. So if you use Pythagorean theorem, -3 squared plus 4 squared equals r squared, which is 9 plus 16, which is 25. So we actually know that r is 5 by Pythagorean theorem. So now I can actually find, if you think in terms of this is theta, we can actually find sine, cosine, tangent. So the sine of theta is the opposite over the hypotenuse. Cosine of theta is the adjacent over hypotenuse. And tangent of theta is going to be the opposite over adjacent, which means cosecant is going to be the reciprocal. Secant is going to be the reciprocal. And cotangent is going to be the reciprocal. And we have now found all 6 trig functions of theta. So on this one, I would like for you to pause the video and attempt to do this problem and then resume to see the answer. Okay, so this is 4, this is -2, so this is the terminal side, and we are drawing a line, which means you create a triangle with the x-axis. Do not draw a triangle using the y-axis. So 4 -2 means I went over 4 and I went down 2. First thing we need to find is r. So 4 squared plus -2 squared equals r squared. So 16 plus 4 equals r squared, which is 20 equals r squared, which therefore r equals the square root of 20. You could reduce it to be 2 squared to 5 as well. At this point, it really doesn't matter either one. So now we can find all the different trig functions. So sine of my angle, which again, the angle is going to be there. So the sine of the angle is going to be opposite. Oh, I need to go ahead and actually write this. Is going to be the opposite over the hypotenuse. Cosine of the angle is going to be the adjacent over the hypotenuse. And tangent of the angle is going to be opposite over adjacent, which is -1/2. Now, cosecant is going to be reciprocal, so it would be -20/2. Secant is going to be the square root of 20/2, over 4. And cotangent is going to be -2. Now, again, we've also discussed in the past, from Algebra 2, you learned that you cannot have a square root in the denominator. So you have to multiply by the square root, basically called rationalizing the denominator. So technically you could say that this was negative, I'm going to run out of room, but sine could also be written as negative 2 square root of 20 over 20, which will reduce to negative square root of 20 over 10. Same thing with cosine. It technically would be, it would turn into the square root of 20 over 5, I believe. And then cosecant and secant are fine in cotangent. Again, if you use 2 square roots of 5 instead of square root of 20, obviously you can reduce it more. At this point, we are not worried about completely reducing algebra 2 information. I'm just more concerned about you being able to figure out the different 6 trig functions. Now, in this case, I do not give you the coordinate point. In this case, I actually give you one of the trig functions, and you have to work backwards. So first, because we're dealing with tan, we're dealing with the opposite and the adjacent, right? So in the 6 trig functions, we know that the opposite was your y value and the adjacent was your x value. Again, tangent is y over x. So therefore, my y value is 5 and x value is 12. So this is the point 12, 5. And so now I can find the other trig functions. Opposite over adjacent. Now, here's the deal though. I have to give you one more piece of information in order to do that, because here's the deal. What if it was both negative 5 and negative 12? It would still turn positive. So you don't know if the 5 and 12 were both negative in order for you to have a positive tangent, because if that's the case, then the point would actually have been here at negative 12, negative 5, which means you would have had this triangle, which is negative 12, negative 5. But I tell you that the cosine, which is x over r, I tell you that the cosine is positive, which means your r is always positive because Pythagorean theorem makes you have a positive number. That means if cosine's positive, that means it had to have a positive value, which means it would not have been that quadrant. It had to have been that quadrant. And now we can find the rest. If that's 5 and that's 12, we can go ahead and at least find r. So 5 squared plus 12 squared equals r squared. So you get 25 plus 144, which is 169, which is 13. Now we can find sine and cosine. So the sine of the angle of this angle is opposite over hypotenuse, and cosine of the angle is adjacent over hypotenuse. Now, here's the deal. How do you in the world determine what's what? Well, again, we know that the cosine of an angle is x over r. We know r is always positive. We know that the sine of an angle is y over r, and again, r is always positive. So, here's the deal. This says that sine is less than 0, which means it's negative. And cosine is greater than 0, which is positive. So, if you think of it in terms as x over r and y over r, cosine, x is positive, and sine is negative, which means the y value is negative. So where on the coordinate plane is x positive and y negative? In quadrant 4. So this might be easy to think of in terms of this. X and y are both positive in quadrant 1. But to get to quadrant 2, I have to go left for my x, but I still go up. Sorry. I had to go negative for my x, but I still went up for my y. To get to quadrant 3, I had to go left for my x value, and I had to go down for my y value, so they're both negative. And then quadrant 4, I went positive on my x, but I had to go down, which is negative. So these are the negative and positive signs for sine and cosine. Again, cosine, if you notice, deals with x values. Sine deals with y values all the time. So I want you to attempt this one. So pause the video, try to do it, and then resume to get the answer. Oh, okay. So sine is positive because it's greater than 1, and we know sine represents y's. Cosine is also positive because it's greater than 0, and it represents the x. So where is x and y both positive? In quadrant 1. So in this one, pause it, and then resume. All right, cosine is your x values. Tangent, tangent is y over x. Cosine is negative. Tangent is negative. All right. We know that the x is negative. So y over negative x. So tangent is negative, which means y cannot be negative. Because if you have a negative y, the negative over negative would actually turn this positive. So therefore, y must be positive and x must be negative. So x is negative, y is positive. Where does that happen? It happens in quadrant 2.